All right. Geometry review. This is for test 1 through 5. There's 20 questions here. Should match pretty close to what's on the test. First question, which set of 3 points is collinear? What does the term collinear mean? What does it mean for 3 points to be collinear? If we don't know this, we won't know it on the test. If I don't know what collinear is, then I don't know how to pick my points. They're in the same line. So 3 points that are in the same line. All right, which 3 points are collinear? Let's see, you should see E, F, and G are in the same line. You could look at all the rest of them. You know, if it will form a triangle, then they're not collinear. Okay, so JFH forms a triangle. FGH forms a triangle. Yeah, 3 non-collinear points make a plane. All right, we're just looking for a line. And what, EFH, there's another triangle. All right, so we want 3 collinear points. Okay, so that's what we get. We get A for an answer right there. Okay. Which set of the following is not an undefined term? We talked about undefined terms in our very, very first lesson. There were 3 things that we talked about that were undefined terms. What were they, Marcus? Lines, points, and and planes. Lines, points, and planes. Okay. A line goes forever and ever in 2 directions, one-dimensionally. Okay. Plane goes forever and ever 2-dimensionally. Okay. So in essence, not every direction, but in 2 directions, but 2 dimensions. And then a point, how is a point undefined? It's there. It has location, but it takes up no space. All right, so it's undefined in terms of its size. Okay. What's that? So a segment is the only one up there that is not an undefined term because a segment has length that can be measured. The rest of them have there's no way to measure them because they're either infinite or not there at all. Okay? Well, 2 endpoints. All right, because technically speaking, a line has 2 points, right? Because between any 2 points is a straight line. But so we're specific that a line segment has 2 endpoints. It has a beginning and an end. Okay, therefore it's measurable. So A is our answer there. Okay, you'll notice that on a lot of these, there's no work to be shown, right? It's just knowing the terms and what they mean. Okay, which is nice for this first test. Okay. If there's no way to show work, then you can't. I mean, basically, you would, like on that question, I would, if I was you, all right, I would be as descriptive as possible. A line segment is measurable, therefore not undefined. Okay? Something along those lines. Does that make sense? And if I were you, I would write, I'd write a statement like that down today. That way I can remember it tomorrow. Okay? All right. Now we're getting into some stuff that is actually mathable. Okay? We can actually calculate. Point B lies on AC between A and B. Don't confuse between with in the middle. Okay? Between just means between. All right? Michael is between Marcos and Katie, but he's not the midpoint. Okay? So don't confuse between with midpoint. You follow me? All right. So here, anytime I've got something like this, what do we want to do to start with? Draw it. Okay. Notice that this is that a line or a line segment for AC? Segment. How do we know? Doesn't have arrows. Okay. So we've got A, we've got C, we've got B somewhere in the middle, right? Or not in the middle, but in between. Okay. It says AB is 3x minus 8. Okay, well, we know that BC is 5x plus 3. Okay. Let's see. Do they give me anything else? No? Okay, that's all the information I've got. It says find AC. Look at your possible answers. Are we going to solve this for a definite number? No. All right. So this is, does anybody know what postulate we would use to solve for AC? Yes. You're going to combine like terms because what we're going to use to find AC is the segment addition postulate. Okay, the whole segment is made up of the two segments. So we're taking 3x minus 8 plus 5x plus 3. Okay, so what's next after that? Okay, so we've got 8x, what? Minus 5. Negative 8 plus 3, right? So we get A for that answer as well. Okay, everything's going along pretty well at this point. Nothing that we can't do. Okay. All right. This test, I think, is usually, although it's probably the easiest test, for some people it's the most important test because everybody starts out first quarter, you know, so long as you've been consistent with your homework, you're sitting there with 100%, right? I think we've got this, and then we have one bad test, and some people never recover. I'm saying that they couldn't recover, but they just don't because they feel, you know, I went from 100% in the class, now I've got a 60% in the class or a 70% in the class, you know, why even try from this point on, all right? Don't get that way, but if you know you are that way, let's really make sure that we nail this thing down. All right, number 4. Okay, we've got RT bisects QRS. If measure angle QRT is 36, what is QRS? All right. You have to start off by drawing an angle. Do we know how to draw an angle? Okay. So with these, I usually make them obtuse so that I have plenty of room to work. Okay. You could make it acute. It wouldn't really matter. Okay. And they tell me I'm working with Q, R, S. All right. Can I move Q and S around? Could I switch those spots? Yeah, I can. I can. Yep. But what point can't be changed in this? R. R has to be, what's the term for where R is at? What do we call that? This is where terminology is important. The vertex. The vertex. Well, it's not, we're not on a coordinate plane, so we wouldn't call it the origin. All right, so the next thing it says RT bisects this angle. What does it mean to bisect the angle? Chandler? Split it in half. Split it into two equal congruent angles. So you need to be able to do this. Okay? RT. All right? And because it bisects, it's dividing this into two equal angles. See how much information is there that I can work with, but if I don't know the terminology, I'm not going to be able to draw that. I'm going to go out on a limb and say that nobody in here has even looked at the vocab flashcards that I sent out for lessons 1 through 5. Has anybody got on Quizlet at all? I sent it to you. It's in your classroom. All right, you can go down through there and find Quizlet. It'll say lessons 1 through 5. Has flashcards for all of the stuff that we're covering. Probably because I have lessons 1, lessons 2. I think 1 and 2 are together. Probably 3 is its own thing, and then 4 and 5. But you could open up all of those and study everything that I'm asking you about, right? And it'll give you flashcards to quiz yourself over. All right, so in addition to watching this video, I think you ought to do the flashcards tonight. You're not getting any homework, right? All you have to do is study for this test. All right, so it says QRT is 36 degrees, right? Put that in there. What is QRS? Well, that's the whole thing, okay? If I know half of a whole is 36, then what is the whole? Double the half, right? Okay? Or I could say, well, I know that TRS is also what? 36 degrees. Okay, in which case 36 plus 36 or 36 times 2, but I should get 72 degrees. Right? If this is the easiest test that we're going to get, you guys ought to be jumping on these questions that I'm asking. If you don't know the answers to these questions, things do not bode well for tomorrow. All right? So maybe you just don't want to answer questions because it's your first class of the day and you're kind of blah, but you're not giving me a whole lot of confidence that I've actually taught you anything. Okay, question number 5. All right, here we have BD bisects. Hopefully we understand the word bisect now because we just covered that. So ray BD bisects angle ABC. So that angle I just drew up there with QRS, could I redraw that and just change the labels? Yes. Okay. Okay, what do I call this point right here? Just asked this question 2 minutes ago. What do I call that? The vertex. What point goes on the vertex of this angle? What do I name it? B. Good. Does it matter what goes on those 2 points? But what are my 2 options? A and C. Okay? All right. What do I need to draw coming from B, but in between A and C? A ray. Okay? What's that point right there? D. Very good. All right. We're jumping on this. All right. ABD is 6x minus 5. All right, and we do know that this is a bisector, so I'm going to label that so that I hold on to that information. DBC is 2x plus 7. All right, it wants to know what this is in specific degrees. Okay, so what are my steps here? What do I do? I know that those 2 things are what to each other? Congruent, right? They're equal to each other. So what can I start with? How do I know it's 180 degrees? It's not a linear pair, right? They don't form a straight line. I just drew the angle. I could have drawn it however I wanted. I don't have enough information to assume that they equal something specific. What do I do know that they equal, though? They equal each other, don't they? Okay, so can I set them equal to each other? All right, so I can say 6x minus 5 equals 2x plus 7. Correct? Okay, now what? But in the end, what I'm trying to do is solve for what? Solve for x. Okay, now does my question say find x? What does it say? Find measure of angle ABD. So in the end, what am I going to have to do? Once I've solved for x, plug it back in for the equation where ABD is. Okay? Right? The biggest mistake in my classes over the years has been students who stopped by solving for x and did not answer the question. Okay? So, you said add 5 to both sides, right? And you'd probably subtract 2x from both sides. All right? You're going to get, 4x equals, what, 12? Right? Divide by 4, x equals 3. And so you'll see, boom, 3 degrees. See, the test is set up to give you answers that you would get if you made the mistake of stopping too early. Okay? But we don't want to stop there. We want to plug it into ABD. Now, it really doesn't matter which one I plug it into. Why doesn't it matter? Because they're the same. So I could come over here where I'm dealing with addition and say 2 times 3 is 6. 6 plus 7 is 13, right? Or 2 times 3 is 18. 18 minus 5 is 13. Either way, I should get 13 degrees for ABD, and I've answered what ABD is. Okay? Don't assume that you're going to stop with x. Sometimes you do, but always go back and check, what is this wanting me to solve? All right. 6. Identify all points of intersection of lines shown in this plane. Even without the multiple choice options, this should be fairly easy. What are my points of intersection, Jordan? P, G, and R. Okay? P, G, and R. Okay? All right, that was pretty easy, correct? All right, so there's some tougher ones where you actually have to draw and be able to draw something accurately to determine what it is that I'm working with. I've got to write an equation. I've got to solve for x. I've got to plug x back into a previous equation, right? There's some higher order thinking involved in some of these, and some of these are pretty direct and easy. All right, 7. Identify the plane in the diagram that contains AC. So I want something that includes the line of AC, but what do I have to have in order to identify a plane? I have to have something specific. An angle? There will probably be an angle between points, but I have to have something very specific. I got to have non-collinear what? A non-collinear line. That's impossible. A line is linear, but you're on the right track with non-collinear. What do I have to have that's non-collinear? I need exactly 3 non-collinear points. So what we're saying here is that this is line AC. So I need something, I'm going to need 2 points that are on that line, third point that's not on that line. Okay? So this first one says ACR. Are those 3 non-collinear points ACR? No. Okay, so that won't work. WCT. Well, one, WCT are not 3 non-collinear points, and they don't contain AC, right? That doesn't work. What about WRT? And this one I don't guess identify the plane and diagram that contains AC. Technically speaking, because, let's see, WRT contains a point on that line. Technically speaking, it contains the line. Because if you look at RCA, RCA is just the line again, right? All of these others are just lines. The only one that's a possibility is WR and T, because those are the only 3 non-collinear points that we have. Okay? But because it contains a point that's on line AC, it contains line AC. You with me? Okay. So sometimes the best, well, not the best, but sometimes the best thing that we can do if we don't completely understand an answer is to eliminate all the ones that are clearly wrong. Okay? Now, I'm fairly certain, I haven't gone back and looked at this test. I probably will look at it again tonight. But I believe that this test will be in bulk multiple choice. Throughout the year, I'm going to start removing multiple choice options, okay, and having them be fill in the blank, okay? But this first one out, I want us to have a good start, get used to the concepts, those types of things. Question 8, identify 2 parallel lines. All right, Katie, can you identify, I don't even care about the answers, can you identify 2 parallel lines for me? You said HE, okay? So this line is parallel to what? Did you say AD? Yeah. Yeah, that would work. Okay. All right, anybody else? Michael, you had your hand raised. Parallel lines? EH and BC. Yeah. As far as I could probably quibble about it and say maybe not necessarily because we don't have our parallel line indicators. So for this question on the test, I would say what lines would I pick that would guarantee that they are parallel? H, G, and E and F. Good, because I have those parallel line indicators. It's not saying that those others aren't parallel, but they may not necessarily be. All right. Skew lines are lines that are not in the same plane and don't intersect. So a skew line would be something like HG and FB. Okay, they're not in the same plane. They're not going to intersect. Okay? All right, that's a good question. Okay. Let's see, we want to look at these lines here, TU, and it usually helps me to go ahead and highlight them. TU and RU. We want to know, are those parallel, perpendicular, or skew? Again, this should be a fairly easy, quick one to answer. What do you think, Marcos? They're going to be perpendicular, if anything. What I wish that they would do is give me the box, so I can verify that they're perpendicular, because technically speaking, they've not given me any parallel indicators or perpendicular indicators. I just kind of have to go based upon appearances, which is not a good way to do it. But yeah, that's what we would get. All right. Now we're get into our numerical stuff. How many non-coplanar planes define space? Does anybody remember this answer? Marcos? Nope. 3. The magic number is 3 there. Okay? 3 non-coplanar planes define space. All right. Let's come down here. We want to know the distance AC of AC on the number line. All right. Now, you could count, but that wouldn't be a very good way to show me your work. Okay. In terms of the math, what symbols, what grouping symbols do we use to find distance? Go ahead. That's what you've learned most recently. What he's saying is A plus C divided by 2. Find the midpoint. We want to just find the distance. Distance is always... Okay, distance is, maybe to change my question, distance is never negative. Therefore, distance is always positive. What symbols push to have something positive? Absolute value. All right? So we're going to do absolute value of A minus C. Okay? You could also do absolute value of C minus A, because it doesn't matter where I start from or where I'm, to where I'm going. Okay, so long as I'm subtracting both. So in here, what is A? 3. What is C? Negative 3. So 3 minus negative 3. Okay. All right, so we get 6. Right? You could do it the other way around and get negative 3 minus 3. You would get negative 6, but the absolute value is still 6. Okay? Now, that's a whole lot better than, 1, 2, 3, 4, 5, 6, because we won't always get such an easy number line. Okay? But if that's the best I can do, can I show that work? Can I show counting? Okay? Then draw me a number line and show me the counting. Okay? Don't just give me 6, because here's the thing. If you can show work, show work. Because if I just get an answer, because today, because it's a memorized, hey, this is the same question, it was on the review, and so I've just memorized the number 6, you're not going to get credit for it. I'm going to write DSA on there, which means does not support answer. Okay? Show me the work. Now, when we take the test tomorrow and you're not sure, you raise your hand and say, hey, this is the answer. Do you expect me to show work? And if I say yes, then you better figure out, either write me a sentence on how you got that answer, or show me the work that you did in your calculator, or show me the work that you did in your head. All right, but don't give me just a number. All right, I want to know that you know how to get there every time. Okay, that this isn't a guess and it's not something that's memorized. You follow me? Okay, otherwise you'll get DSA'd on it. I don't want to DSA you if I don't have to. All right. Let's see, number 12. Point F lies on EG between E and G. This is just, we're kind of going right back up to some of the other questions that we've done. What do I need to do here? Draw a line segment. Good, thank you. Okay. E, G, F. Okay. EF is 2. EG is 14. Okay? You know what mistake most people make with this question is they will put 14 between F and G. One is that E and F look fairly close just visually. Okay? 2 is that we get used to that segment addition of just doing, okay, this half of the segment is this, and this other part of the segment is going to be this. Here they give you part of the segment, and they give you the whole segment, and ask you to find the missing part. Okay? All right, we can put X in there. Can anybody tell me what equation we might write to solve this? We could still use the segment addition postulate. It's just going to change because we actually know what the solution is. 2 plus X equals 14. Okay, subtract 2, right? What does X equal? 12. Plug it back in and check. 2 plus 12, is that 14? Yes, it is. Okay, maybe you know right off the bat, hey, I drew the picture, I'm going to take 14, I'm going to subtract 2. At least show me that, all right? You don't necessarily have to do the 2x or 2 plus X equals 14. If you can show me, hey, here's the picture, this is where everything goes, I'm just going to go ahead and jump to 14 minus 2 and fill in the rest, okay? All right, 13. Find a measure of the angle formed by the hands of a clock when it's 3 o'clock. Here you might actually have to know something about a clock. All right, 12, 1, 2, 3. Okay, 4, 5, 6. Right, 6 is straight up and down. All right, you could do 7, 8, 9, it's directly across, 10, 11. All right, there's your clock. When it's 3 o'clock, right, where's the shorthand? Points directly over at 3. The minute hand, straight up at 12. Anybody know what angle this is? That's a right angle, 90-degree angle. Okay? Now, one of the ways I could test this is that there are 12 spots around that clock, right? That means there's 360 degrees, correct? So I could take 360, divide it by 12, and find out how many degrees each hour represents. Right? I think that you'll get, what, 30 degrees? All right, so each hour represents 30 degrees as you go around. So there's 30, there's 60, here's 90. Okay? That's going to guarantee I know what's going on. Yeah. In addition to it, you might also want to show me, hey, what hour, because on the test, it might say, hey, what's the degrees at 4 o'clock? Right? Well, that's not as visually as easy to see as 3 o'clock. I'm going to have to add another 30 degrees. So 4 o'clock is actually what? 120 degrees. Right? 5 o'clock is 150 degrees. 6 o'clock is 180 degrees. You see, once I understand that each hour on every clock like that is 30 degrees, now I can more easily do that. Granted, by the time I get back to 7, right, now I'm going back down. Okay, it's not getting bigger and bigger. All right. Let's see, number 14. Identify the coplanar and non-coplanar lines. This is kind of a trick question because do those two lines intersect? All right. What do we know about two lines that intersect? All right, this is, what's that? They intersect at a point, but any two lines that intersect will form a plane. All right, because this is what happens, right? There are 2 points on every line, right? Okay, so here's a point, there's a point. What do I have just at those 3 points? Those 3 points are what? They're non-collinear, right? So 3 non-collinear points form a plane. So 2 lines that intersect have 3 non-collinear points, which means any 2 lines that intersect are coplanar. There's no non-coplanar lines unless I had a third line in here, and I don't have a third line, so they're all coplanar. There are no non-coplanar planes. It's a really wordy sentence. Okay? All right, let's try to get at least 1 or 2 more done. All right, this one works on that same premise, the exact same premise. Here I've got line L, here I've got line M. Do lines L and M intersect? Okay, so here's my question. Are they coplanar? Yes. Just because they both exist on different planes doesn't mean that they don't exist on the same plane as well. So what I could have, and what I do have, is this plane that they both are on. Okay, and I can't draw that very well. Let me see if I can. Go ahead. What's your question?
What about that line that's off the
This line? What about it? Is your question I mean, that line there is the line of intersection between the 2 planes that the planes intersect at. Okay, but we're talking about lines L and M. Okay, so we're not asking about, the line of intersection of the 2 planes. But the same truth still holds. If 2 lines intersect, even if they both exist on separate planes by themselves, when they intersect, they exist on a plane together. Okay? I just can't do a very good job of drawing that. All right. So your answer, are they coplanar? You're going to say yes, because any 2 lines that intersect form a plane, or are coplanar. Okay? 6, this is where you want to go back and you want to look at those flashcards. Okay, because a lot of geometry is theorems and postulates, and this stuff is based upon that. Identify the property that justifies the following statement. If AB is congruent to CD, then CD is congruent to AB. Does anybody know what property that is? So you feel like this stuff is easy because we're not adding anything that's all that hard, but we don't know our properties, theorems, or postulates. What is this? It's the symmetric property of congruence. Okay? Means if my right hand is congruent to my left hand is congruent to my right hand. I can flip them. Okay? But that may not be the property that gets addressed on the test. So do you need to look at those flashcards? Yeah. Okay? What is the angle of the hands of the clock when it's exactly 8 o'clock? All right? So go back to your clock. Well, we're on the other side now, though. Right? Oh, gosh, I didn't even do that right. Okay, so you got 11, 10, 9's at 90, but now we're at 8. Okay, because we're looking for this angle. Okay, so we're not going further around, so it's 120 degrees. What's that? No. No. You guys won't probably deal with very many negative degrees. Okay? All right. So we stopped there. I'm going to finish up the other few questions with the other class, and then I'll send out both videos together. All right?